Yep. Quentin wants to check that we were not recording yet, but thank you very much. Anyway, this is the very first lecture, and we are not going to pass through a lot of terms and notations today. We just start that course. But once again, thank you very much. Well, speaking about the course plan, you just started a year at DSBA program. Actually, well, I tend to say that you did a very good job. Come on, guys. You had to pass these COVID-19 issues. You were under the stress. And really, I'm very proud about yourself, about you guys, you all, because, well, that was not so easy. And I cannot even imagine what sort of stress you have passed through because of these online exams and all of that, online exams. So that was pretty tough. This course is going to be more data oriented, although we are going to start with the basic definitions and then we will pass through. So speaking of the course plan and the course structure, I would like to highlight the following. The course might be split into two parts. Well, the first part is called the probability theory. By Russian, you'd usually say теория вероятности и все такое. The second part of that is called statistics. Well, although Russian books say математическая статистика or mathematical statistics, this is pretty Russian-oriented story. I mean, the way this might be called. I was teaching at the London School of Economics, and while I was a PhD student there, we used to say statistics only. Well, you know, none of the UK-oriented book ever say mathematical statistics because this is pretty obvious. I mean, it is impossible to play with these concepts without any mathematical skills. Therefore, thanks to your first year calculus, hopefully you were pretty advanced with that. We are going to apply some of the calculus methods, tricks, and formulas. So let's go back to the course structure. We are going to start with the discrete case. All right, so with the discrete definition of probabilities, and we will present some of the probability distributions. Then we will switch to the continuous state case when you are supposing that your random variable is a continuous one, but hopefully you do distinguish what the difference between continuous and discrete is. That was a joke. Now you may laugh. You should get a smile on your face and get your cup of coffee. Well, if you have, of course. The second part of the course starts to be slightly more advanced. So basically, the first module, maybe the first module and a half, are going to be pretty obvious and pretty standardized. But the second part is going to be oriented to test the hypothesis, to analyzing a framework. All right. And that is going to be slightly more complicated. It is less obvious, all right, but we are going to enjoy that. Just to structure the way we are going to get in touch with each other, if you have any connection issues, please do not hesitate to text about that to the Zoom chat or say that as loud as you can. I hope we're going to be permitted to meet each other offline on the Pokrovsky campus, hopefully. But anyway, so I just said the main advantage and the bonuses you are going to get if you master that course. Then I said the course structure and the main plan about that. Now let's speak about books. All right, so it's pretty complicated to wake up a Saturday morning, but that might be pretty complicated actually. Anyway, if you don't want to attend these lectures, you may pass through some of the books, but in case if you want to get some extra reading, you may use these books as well. The course we are going to conduct is basically UL structured, and is going to be conducted in the UK manner in a way. So the main book is Newbold Carlson book, that's called Statistics for Business and Economics. It's a pretty nice book, very simplified. So it might be your first book if you want to get some revise, so if you want to read some extra stuff. So basically this nice book to start with. If you have any problems with English notations and all of that, you may use a very nice Russian written book, so Gmurman book, Fundamentals of Probability Theory, Mathematical Statistics. This book is actually written in 2 languages, Russian and English as well. And if you want to, you may do that. You may read this book in Russian, although I do not recommend to do that. And the reason why I don't recommend you guys read any book in Russian is not because you are studying at the DSBA program, because you are going to get the University of London exams this summer. And the main problem is to recall all of the notations and terms in English. If you study probability theory in Russian and then try to interpret that and translate that back into English, it might be a huge problem because it's not that straightforward. I do not doubt about your English skills, and I fully sure that your English class teachers did a very good job and you get some skills. But speaking of vocabulary, it might be huge. It might be a huge problem actually. So be very cautious. Do that partially if you wanna. Again, I would definitely recommend to use some online resources and all of that. But these books are very nice one. For those of you who want to get some advanced stuff, so if you feel that the problem pools and sets we are doing on lecture or while your classes are pretty obvious to you, you may use a book of the very famous Italian mathematician Casella. It's a very nice book. I mean, the statistical interference, pretty advanced. So based on that course and all of the stuff we are going to discuss each other, it might be a very nice one. All right, so we said the minimum. So I said the plans and I said the books. I just mentioned that this course is a UK-based and UL standardized. So by saying that, I mean the following. Look, by the end of this year, you are going to attend 2 University of London exams. When I was a master student at the University of London, and then got promoted to the PhD student, I was thoroughly involved into University of London exams designs and problem preparations. So we've been teaching these course for the last 10 years, and I would say the following. Well, these 2 University of London exams are not that complicated. I might imagine that you have had some conversations with your friends from the 3rd year of studies who shared with you their experience of University of London exams. These 2 courses, I mean Statistics 1 and Statistics 2, are not that much complicated. The only problem that students have to pass these 2 exams suffer with is the sort of what's called the interpretation. So, once you got the result, say, a formula, you got some data, you evaluated it, and you got the result, and then you have to present this result. So you should be able to interpret what x equals 5 means in terms of your analysis. And that's a great problem, because in order to be able to do that, you should be familiar with all of the parts of definitions, of theorems, of formulas, and all of that. So this course does say that you will need to study a lot of new material. You will need to remember a lot of new definitions in order to be able to play with them, like the balls and circles. Once you pass that, and I hope, hopefully you pass that successfully with excellent grades, you will get then promoted to the 3rd year of studies, where you will be proposed to attempt the second part of the course. So while I'm teaching the 3rd year statistics as well, and it's called advanced statistics, and then you will be proposed to pass the next 2 UL exams. Basically, speaking of UL exams, you are now on the, let me do some writing. You are now, you're 2 students. By the way, hopefully you get, you mastered your English vocabulary. So you know that the 1st year students are usually called as freshmen, like, well, they came new to the university. And you know how the British say about 2nd year students? How they call them? Well, if you know, please text that to the Zoom chat. Well, otherwise I will think that nobody is trying to listen to that, and I'm speaking with myself in my office, and so this sounds strange. Yeah, that's true. That's sophomore, absolutely. Brilliant, Matvey, that's brilliant. And yep, you are a sophomore. Enjoy that. Once you go to the year 2, year 3, you will be then proposed to pass these advanced statistics. So this year, we are doing a course called statistics. And then for those of you who survive that, we'll meet again in a year with the advanced statistics. And the reason why I'm saying that is because these advanced statistics course is entirely based on what we are going to do this year. The same definitions, the same principles, the same axioms. The only difference is the distributions and slightly more advanced definitions of features and characteristics of the probability distributions. We'll get into that. Now let's speak about the final grade. So here we do present the main exams we are going to have. The first model, if I recall correctly, started from the 1st September. It's going to be till 23rd of October, sort of that. Then the second one starts sort of the end of October till the end of December. Then you got some holidays, winter holidays, you're doing some skiing, you enjoy your time, you do forget all stuff, and then you go back, I don't know, about 10th or 11th of January, we start back our studies till the sort of the mid of March, something about that. And the last month, the first month of the 4th module, this should be about April, or about that. So starting the April till the beginning of March, of May, we will be then preparing to the University of London exams. So the first model terminates with the fall mark. Well, if you know why I use this term, well, actually, you do know what sophomore means. That's very good. And what mock exam means. If you know, please text that to the Zoom chat. The second module terminates with the winter exam. Then we'll have some minor exam by the end of spring. And the last module, I mean, the April, is going to be allocated to master the YOL exams. We will be solving a lot of YOL exams. We'll be doing a lot of problems of that. And then I will present you the main framework, like the YOL examinations is conducted, the structure the framework is structured as well. And I will provide you a full list of tricks and hints in order to you be able to prepare before the exams. It is a very nice exam, and actually about 4,000 students are writing these exams every year. So a lot of your international classmates are going to take the same exam. And I may guarantee that my class teachers and I will do the maximum in order to provide you a broad introduction into the area of probability definition and statistics as well. And we'll do maximum in order to prepare you before the exam starts, before the YOL exam starts. This is actually a highly important exam to you because it's gonna be part of your London School of Economics diploma. And the mock is an exam which is almost the same format. Well, actually, no, they're very nice, actually, very nice attempt. Well, if you know some French, well, actually, English is not my first foreign language. My first foreign was French, and French say "se moquer de." This verb means, well, in Russian it means издеваться, пытать, унижать, доставлять моральные неудобства. And actually, this was the reason why some of my friends from London School of Economics, they like to see, instead of exam, they call this mock exam. I'm just kidding. Enjoy that. Let's go back to formulas. All right. So here on the screen, you have the all formulas, how your fall score and the spring score is going to be structured, and the total score as well. If the exams are conducted online, if the exams are going conducted online, then we will split the every exam into two parts. The first part will be written-based exams, so you will get some written part, and then you will get some oral part where you will have to present your solutions. And the second part, where you will have to present and defend your solutions, is going to be structured in the following way. So you're going to be then proposed with 5 questions. And if you do not, well, all of the questions are going to be based on the course. If you do not, or someone does not answer a question, then a final score is decreased by 1 point. Well, actually, it's measured out of 10. All right. And if you answer that question, then, well, your score does not decrease, and you stay with the same score that you got with your written part. The same framework is going to be applied towards the homeworks. We're going to have about 20 homeworks during this academic year. It's not that much, about 4 or 5 homeworks per module. Well, I would like to conduct this course in a very comfortable way to you guys, because I do realize that it's not that easy to study online and offline partially, and I do understand the stress that you might have with you might tackle with. Therefore, I would like to make to run this course in a very nice way, and I expect the same attitude from your part to us. So cheating is strictly prohibited. All of the homeworks, you might see their weight at the total mark score is not that huge. And I highly recommend you to do all of the homeworks yourself. You are allowed to share your ideas. You are allowed to share your things. You may cooperate, but you are not allowed to cheat with the homeworks and present the same solutions. All right, it's a very sort of a gentle border that I would like you not cross over. Therefore, if some of the class teachers suppose that the homework solutions were cheated, then both of students will be proposed to present these solutions, and then they will be presented with 3 questions, all right, about the problems given at the homework. And the same pattern is applied then. If you do not answer any question, if you do not answer a question, then score is decreased by 1 point out of 10, of course. So the maximum loss you may get is about 3 points, but you would get much better if you are practicing your homeworks, if you are getting feedback. Come on, in a year or 2, you're going to be working at Yandex or Sberbank or Tinkoff as a data analyst and data science. So you should get some experience of feedback and your solution structure. It's a very business-oriented style. And look, I'm working at the Moscow Exchange for the last 2 years. So, and by the way, speaking about my profile, well, I got a mathematical degree. I used to live in London for a couple of years doing some research there, but I mainly specialize with the financial area. So the quantitative analysis and the quantitative research. And currently I'm head at the Moscow Exchange department. And I would definitely recommend you to practice as much as you can, because once you're doing any mistake, you will get some better expertise into that area instead of cheating and get some extra point. That's, well, my kind of recommendation. All right, we discussed my profile, we discussed the course structure, the class teachers. I'm going to conduct a lecture, and hopefully on some of the days we meet at the any room of, and you'll see at least how I look like, and I see your guys. Hopefully, well, if you see me on the campus, please say that you are one of my students. I would be happy to meet you offline. But currently, the classes only are going to be conducted offline. The first group is going to be conducted with Anton, and the rest 3 groups are going to be taught by Alexander. So these are your class teachers. And at the first module, you are going to have 1 lecture, 1 class. At the module 2 and 3, you're going to have 1 lecture and 2 classes. At the module 4, we'll have 1 lecture and 1 class. Well, as I said, the meat of the course is going to be very intensified. This is good because the topics we're going to play with in couple of months are pretty computationally extensive, I would say this way, and you will benefit from some extra practice. All right, so these are your class teachers, and hopefully you're going to meet them. Now let's speak about the interactions. I have organized a Telegram channel. All right, so I hope that you prefer Telegram instead of WhatsApp, but if you wanna do any group chat at WhatsApp, do not hesitate to do that. So here's the link to the Stuttgart Telegram channel. Oh, hopefully you have you had watched the movie with Bruce Willis called The Die Hard? Well, I actually like this movie a lot, and I thought that this course should not be that obvious. It should be hard, it should be complicated. That was the reason why I called this Telegram channel It's That Hard. So please join this Telegram channel. We're going to share there all of the lecture slides, all of the updates. If any problems with the time schedule happening, we will post this there. So this way is the first we are going to share all of the information. Oops, yep, that's good. So all lecture slides, homeworks, all of these is going to be posted here. Plus, I think that there are some nice online resources where you may watch some nice lecture or some extra materials. Therefore, I will be sharing with you guys all what I know, and I will share their online links to some extra materials. So hopefully this will give you some extra information. Plus, I will be sharing all of the course updates, I mean, deadlines and updates. Besides that, well, I was sad actually yesterday in the afternoon that HEC is going to introduce some LMS system. It's called the Smart LMS. So some days another online system is going to appear that will post these Smart LMS info system. Well, I don't know actually what it's going to be about. It's going to store the sort of course structure and some books. Again, what I tend to highlight is that the main way to get all of the course information is actually this Telegram channel. So please share this with your friends if they are not attending this lecture. All of the homeworks are going to be posted there. By the way, if you got in troubles, or you have a very funny joke or a very nice story that you'd like to share with me, please do not hesitate to text me. So you are allowed to write me with all of the problems, except you went out of the club on a Friday night and you got caught by the police. In this case, you should call your lawyer. In all of the other cases, you may write to my personal email. So it's my last name, Lukashenko dot my name in French, Pierre at gmail.com. Do not hesitate to do that if you have any questions or recommendations or advice. Well, if you know, and if you have any advice to make our course more interesting and to do it more useful to everyone, please do not hesitate to write your ideas. In other cases, I would like to make these time allocated on that lecture as useful as possible. I do appreciate your attitude. I do appreciate your time and my time as well. Therefore, once we met here via Zoom, let's do that as useful as possible. If you have any questions, do not hesitate to write them at the Zoom chat. Straightforward, we'll get into that. All right, so now we do know each other. We have we share the contacts. Some of you will send me very some nice jokes and the motivators as well. All right, what's next? And hopefully now we might start with minor introductions again to highlight. Today we are introducing the course. This is the first lecture. So hopefully you're already in Moscow and you are going back to switch into education mode. The probability is actually a pretty intuitive definition, although it was introduced by various mathematicians. Well, by saying various mathematicians, I mean Kolmogorov, Euler, Gauss. Well, you know, the Gauss was introducing a lot of linear algebra that you were studying last year. Well, Kolmogorov was one of the major mathematicians who developed the axioms of probability theory. Plus, Lorentz Bayes did some nice stuff. And actually, by saying probability, we usually tackle with a concept of likelihood. By saying probability, we are trying to introduce any quantified measure in order to compare what how an event is likely to happen. All right, so you do know that probability is actually measured from 0 up to 1. We usually say in percents. For example, what is the probability that you pass this course by the end of the year? Well, you may say 60%. That's pretty fine if you say that in real life, but in terms of the mathematics, the right way to say the probability is 0.7. And actually, this is one of the issues where the whole exam scores are decreased because of the definition. The probability is measured from 0 up to 1. And here we have a pretty simplified example. You have n white balls and n red balls, and a pretty obvious question: what is the probability if I try to get on random a ball out of this box? Well, in this case, you might say that a probability is intuitively close to the frequency. All right, so you might say, look, I may reduce that, I mean selecting a ball out of the box for 1,000 millions of times. All right, so I may repeat this. What is the probability that I will select, that I will get a white ball? And in this case, we are very close to say that it is about frequency. I pick a ball if I do that. Well, obviously, you have total amount of balls being equal to n plus m, all right? And only n white balls are there. Then you might you may intuitively guess that the frequency to get them a white ball should be n divided by n plus m. All right. Actually, this is the first definition of a probability. By saying probability, we may present a definition based with frequencies. a probability of the random event is a fraction of a number of good outcomes divided by the total number of outcomes. For example, you have a coin, all right? So your coin has two parts, head and tail. Then the question is, what is the probability of head? Well, if you say that your coin is fair and it is not biased, then you have only one good outcome because your outcome is head. So you have only one outcome that satisfies you. And what is the total number of the possible outcomes? Well, head or tail, so 2. And actually, this is the reason why we see that the probability of the head appeared with the fair coin tossed is 1/2. This is good. That's really good. Now let's say that you got your coin, all right? So you say you are staying now at home or at cafeteria on campus and in Pokrovsky campus if you are there. And look, you might have a coin right now in your pocket. If you get that, you may toss this. You may toss this coin, say 100 times, all right? So you do that 100 times. You retoss the coin and you repeat that. And now the question is, what is the number of heads appeared there? Is going to be 1/2 multiplied by 100? It means 50. Well, actually, no, it's not going to be 50. If you toss the same coin 100 times, you may get 48. Some of your classmates may get, say, 47. Another friend of yours may get 51. And these are going to be the results of the same experiment. And now a pretty obvious question should be raised. Why they differ? And actually, we are going to spend a full module, the first module, in order to realize the main difference of that definition and these results, because what data science do, they play with these data sets. Well, hopefully you have had some talks about the data science area, and hopefully you know that all of the data science research starts with the data set. All right, so you should have some data set. And the key part of data science job is to evaluate the probability based with data set. Well, if I have some random variable that might appear with 48 or 47, how may I guess that it should be 1/2 probability of this? Ideally, I would be happy to say 50 as a number of heads after 100 times tossing a coin, but honestly, I will never see this. And the reason why the difference of that is actually the main area we are going to point our accents for the next 3 or 4 weeks. Here I should start with the concept of experiment. All right. So by saying experiment, it's not like playing with rats or mice in a laboratory doing some nuclear experiments and all of that. No. Well, experiment means any story, any action that you may measure with the probability and you may repeat. If you cannot repeat the experiment, this is not an experiment. It's called a survey, or it might be called as an evaluation as well, or it's usually called as study. For example, you may do the following experiment. You may go to every to every classmates you have and ask how many friends he or she has. And this experiment might be repeated at any area. You may do that on campus or in the neighborhood where you do live or in your hometown and all of that. So these can be repeated. While study is it's sort of a data collection procedure that cannot be repeated. For example, let's say you have a rocket, all right, spacecraft, and you want to measure the speed it flies to the moon, especially these spacecraft. So you burn it, it goes upside, it reaches the moon, and you have some laser and you measure the speed. Can you remeasure the speed of the same spacecraft? No, because it's going to be destroyed there. You cannot return back to the Earth. And this data collection is going to be called a study. Unless you are Elon Musk, who's going to produce a lot of Dragonfly spacecrafts that might be reused, actually. The probability concept starts with the experiments because we say that we want to be able to repeat any of the procedures in order to recheck the results we got. Actually, by running an experiment, we are collecting data. So you will use some data sets, and this data is actually collected always with experiments like coin tossing or rolling a die. These are experiments. And the first definition is a sample space. Here I may do some picture. So I say the following, look, I do say that an experiment have some list of possible outcomes. For example, a Faraday. It has 1, 2, 3, 4, 5, 6 on the edges. A coin. It has either head or a tail. The sample space is a set of all possible outcomes. Well, in my case, 1, 2, 3, 4, 5, 6 are inside the sample space of an experiment that is related to the rolling a die. So if I roll a die, I will get an outcome, and an outcome is an element at the sample space. All right. So this is a set in purple, and the outcome omega, it's an element of the set. So here we presented sort of a picture that may collect the outcomes of an experiment related to tossing a coin. Now let me change an example. And let's say that instead of tossing a coin once, I do that twice. All right, so let's say that I'm tossing a coin twice. And by the way, guys, if any vocabulary problems are, do not hesitate to text about that if you need some interpretation or translation about that. So let's say we are doing the following experiment. We are tossing a coin twice. What are the elements of the sample space? Well, again, a sample space is a collection of all possible outcomes. If I toss a coin twice, what are the outcomes? Well, in this case, I'm gonna have 4 possible outcomes. double head, double tail, head, tail, tail, head. Sample, all right. That's actually, this is one of the most complicated questions. Actually, I'm sure. I'm fair. You know the problem to translate the word performance. Well, honestly, I have no idea how to translate the word performance. If you have any, please text about that to the Zoom chat. Sample означает выборка, небольшое подмножество данных. Sample space means that it is a set of all possible outcomes that might be observed at the experiment. If an outcome cannot appear, all right, Adam, a very nice try. Could you please translate portfolio performance or financial portfolio performance? But let's go back to the sample space. It is a set of all possible observations that you may see if you run some experiment. Say you are going to your friends and you ask how many friends do you have? What is the sample space? Well, the sample space then is a set of natural numbers, because every friend of yours may say, I have 1, 2, 3, 4, 5, etc. friends. But they never say, I have 3.5 friends. That's impossible. If you go to the, say, to the street, and your experiment is to measure the car length. I have no idea why you may do that, but say you need to measure the car length. For example, you are developing a code at Yandex with the self-driving mode, right? Self-driving cars. So you need to measure the length of cars. What is the sample space then? Well, the sample space is going to be a set of real numbers, well, positive, obviously, all right? Because, well, negative length of cars is always impossible. And this is your sample space. So you might say that a sample space is sort of the box. Yeah, that's true. Oh, that's true. Yep, Matvey, very good, very good. And now we do see that you and Gundam actually propose two different interpretations of the same term, I mean, performance. And actually, look, you both do understand what it means. You do feel that and you have some intuition about that's right. But if you were doing these notations in Russian and then trying to transfer it back into English, we definitely get into troubles. And this is the reason why I do not recommend you guys read any books in Russian. You are going to explain your solutions in English at the YOL exams, and they have an internal one. And this might be it might be a great challenge to transfer from Russian into English. Plus, the YOL exams might be conducted in the offline mode, and then you will be proposed with a very limited time. So that's a very nice experience. You can have a negative number of friends as well if you consider your enemies to be your negative friends. Well, actually, it's a nice idea. Well, if we say that every enemy we have is a sort of a negative friend, so it should be multiplied by minus, that's a very nice idea. Then your sample space is a set of real numbers. That's right. Oh, no. I said very straight. It should be a set of integers. It should be a set of integers. That's nice. All right, so speaking of a sample space, you might think that it's sort of a box where all possible outcomes are collected, all right? And you do pick some value. The sample space might be discrete, like here or here. even here, no, or it might be continuous. The continuous case was here. It might be finite, or it might be infinite. Rational number of friends, if you consider chaotic, inconvenience, elder gods, how to tell your things. Smart, that's smart. So when I said at the very beginning of this lecture, well, I said you all guys, that we are going to discuss discrete random variables and continuous random variables. And now you may realize what makes a random variable be either discrete or continuous. It is all about the sample space. A random variable is discrete if his sample space is discrete. Then it is continuous if the sample space where it is located is a continuous one. And the sample space might be finite or infinite as well. So these are two features of the sample space. This month, we are going to discuss discrete random variables only. All right. This module, we are discussing discrete random variables only. And then, once we will be able to play with the discrete state case, we will transform that into continuous one, and that would be pretty obvious. Now look, we had introduced a term of a sample space, like a box where all of the balls are collected. And we said that omega is an element of a sample space. So omega stands for an outcome, and omega capital stands for a sample space. Now we are introducing a random event. So random event stands to be a subset of a sample space. So an event A is a collection of elementary outcomes, like omega smalls, small omegas, and it appears to be part of sample space. And let's do some examples. Speaking of Roldine, a sample space has 6 elements, and these 6 elements are elementary outcomes. Now I may say the following random event. Here I present a random event A that says I wanna get an even outcome. Then, if this random event is introduced, then what elementary outcomes might be collected into? Well, I do collect all of the even values. So it's 2, 4, 6. All right. If I say I want to get, say, random event B says I want to get results greater than 4. Then it says that only 5 and 6 are included into that random event. And here, what we start with, we should be able to to play with these subsets. Hopefully, you have not forgotten your discrete math and your set theory, so you do know that. A basic definitions. If the probability of some event is 0, this event is called impossible. All right. So, for example, if my sample space is a collection of 6 numbers, all right, and I see the following event. Look, an event C means that I get a negative value. What is the probability of that? Well, the probability of a negative event is 0 because there are no elementary outcomes that might be collected into it. And the impossible random event means that it is an empty set. It is an empty set and no elementary outcomes is included into it. The opposite story is certain event, those events that has a probability of 1. All right, so if probability of random event is 1, then we say that it is a 100% certain event. Well, in this case, you may guess that A equals to the sample space because it collects all of the elementary outcomes that are inside, that are into it. And what we are going to do, we are going to compare the probabilities of 2 or more random events. If probability of A is greater than probability of B, then I say that A is more probable or is more likely to happen compared to B. For example, what is the probability to get snowing today, and what is the probability of raining today? Well, although I'm not expert at the weather forecasting, I guess that probability of raining is greater than the probability of snowing. Therefore, both of these events might happen actually, but raining is more expected and more likely to happen than snowing, for example. And actually, this analysis is going to help us to get some intuition about the about what's happening at the data set, and then we will use that in order to describe what is the function that describes this probability. Once we have introduced, oops, that was smart. Please start broadcasting again. I don't want to see my desktop. Oh, that's an iPad. Sorry, guys. Oops. Yeah, we're back online. The definition of the probability of the random event A is a fraction of 2 powers. Well, if you recall the very first definition we just introduced 10 slides ago, we said that a fraction of number of good outcomes divided by the total number of the possible outcomes is a definition of a probability. And now we present a more formal definition of that, that says that a probability of an event equals to the power of a set A divided by the power of the sample space. And this was actually proposed by Kolmogorov. In all of the cases, we are supposing in tricks implicitly that the sample space is finite. We are not dealing now with the infinite sample spaces. All right. So for now, for this month, during the September, I'm discussing with you the finite sample space only. And after a month, we will introduce some minor deviations. Well, as you already got to understand, the definition of random event is fully based with the operations of sets and the basic of operations related to the sets is actually applied in order to combine back to formula. Yep, no problem. In order to combine some of the random events jointly. All right. I'm going to share. Yep. You're welcome. All of the lecture slides are going to be posted straight after the lecture, or maybe in a couple hours after the lecture at the Telegram channel. So you'll get all of these slides. The basics of set theory. You do know these operations: the union, the intersection, the complement, and the subtraction. Let me pass the measurable sigma algebra for a couple of moments. Yep. Sorry. We will. Yep. Now we join back to the main of the probabilities. So hopefully, I'm not going to spend time recalling what the union, the intersection is. I do not doubt about you guys, and I suppose that you have not forgotten this. You do recall this, and all of the set theory. Here are the axioms related to the probabilities. First of all, we say that the probability cannot be negative. It is always either positive or zero. It is impossible to get some negative probable outcome or event. As we said, it either never happens or always happens, or something in the middle. Therefore, the probability is always positive or zero. The probability of the sample space is always 1, so it's maximum. And if two events do not intersect, so if they have no common, then the probability of their union is the sum of their probabilities. So let me clarify this a little bit. Say A is 1 and B is 6. So we are speaking about rolling a die. And you want to measure the probability that you get 1 or 6. So this is defined by the intersection, or by the union. A unified B means that or A, either B happens. Then this probability, if they have a zero intersection, empty set as an intersection, is the sum of these two probabilities. So you get this probability of 1, you add the probability of 6, and you get and you result it with the probability that you get either 1 or 6. All right. So this stands for a very basic definition. As a result, we may define the probability of random event. A probability of a random event is a sum of the probabilities of elementary outcomes that are included into the sample space. If you recall the picture I was drawing 5 slides ago, so I said your sample space collects the elementary outcomes, and the elementary outcomes are those outcomes that never intersects. All right, they are elementary, they are elements, they never intersect. Therefore, the probability of any event is always a sum of the probabilities of elementary outcomes that are included into it. For example, I want to evaluate the probability of even outcome. Then I get a probability of 2, probability of 4, probability of 6, and their sum will give me a probability of my random event. And now we do touch the first part of probability theory, where we need to be able to describe the probabilities of these elementary outcomes. And actually, this is what statistics do. And sorry, guys. Sorry. And the probability theory does. We are going to introduce some distributions, simply speaking, functions that are going to describe the allocation of probabilities across these outcomes, I mean elementary outcomes. And then we will introduce some instruments in order to do fast calculation of probabilities of some random events. And this will be your bread and butter. This is going to be the main instruments of data science and machine learning experts. The main goal of us is to be able to model the allocation of probabilities across all of the outcomes. While the outcomes might be various, any of this, what we are going to study together. Some definitions. If A is intersected with B, then it means that they both happen simultaneously. The intersection of two random events says that they happen simultaneously. They happen at the same moment of time. The union means that at least one of these two random events happens. All right. So at least one of them, either A or B, any of them happens. This is what unions say. I mean union of two random events. A difference. A subtracted B, suppose that only A happens and B never. All right. So only A happens, but B does not happen. This what the difference says. A complement. A complement of a set says that any outcome may happen, but not that outcome that was included into A. So if this rectangular is your sample space, then it looks like a Japanese flag. Sorry about that. So if A is your random event, then a complement means that A never happens and any rest of may happen, but not A. Oops, sorry. If the intersection of two random events is empty, then they are called mutually exclusive. It means that they never happens simultaneously. If an intersection of two random events is an empty set, then it means that the probability that they both happens at the same time is 0. These two random events are called mutually exclusive. There is another term, collectively exhaustive. Well, collectively exhaustive term says that two events are called collectively exhaustive if the probability of their union is 1. If either A or B happens, then they are called collectively exhaustive. All right. What's the rest? So we said the mutually exclusive, we said collectively exhaustive, we said the impossible if the probability is 0. We said certain if the probability is 1. The disjoint events are events that never happen. So basically, disjoint events is the synonym of mutually exclusive. Can you draw the image, how it look like? They are collectively exhaustive. Yep, no big problem about that. It's pretty obvious. So let's say that we have a sample space. I got a knife and I split it like that. So it's A or B. For example, here I have 1, 2, 3, and here I have 4, 5, 6. Or, for example, speaking about rolling a die, A is an event of odd result, and B is an event of even result. And they are both collectively exhaustive then. All right. Superb. Yep, good. All right.
I'm sorry, can you please show intersection once again?
The intersection, so it was somewhere, it was a union, and here it is. So the intersection, we have 2 events. Here's event A, here's event B, and the purple written is their intersection. So basically, any outcome that is located inside the intersection is actually a part of set A and is a part of event B. And if W happens, then actually A happened and B happened simultaneously. All right.
Then what is the diagram for union?
All right. And speaking about union, we say that once A is unified with B, the new event that we get is actually covered by both of these circles. And look, here's A, here's B. This is omega 1, this is omega 2, this is omega 3. And if omega 1 or omega 2 or omega 3 happens, then they are all included into A unified with B. And then I say that either A or B happened. So I do not care which event precisely has happened. I want to be sure that either A or B happened. And voila.
Okay, thank you very much.
Yep, you're welcome. All right, to recap, we had presented the course structure, we have discussed some books, we shared the contacts, and we defined what the probability is. This week, you are going to practice in the probability evaluation with your class teachers at your smaller groups. And next week, we're going to step forward in order to introduce the first probability definition. In all of the case, I am happy to start this course. I'm honored to meet you guys, and I hope that some days we meet offline each other on campus. The rest, I wish you to have a very nice Saturday morning, to enjoy your weekend, and see you soon, guys. Stay tuned.
Okay, thank you very much.
Thank you. Goodbye.
Thank you.
Thank you very much.
Goodbye.
Goodbye.
Thank you. Have a good day.